Okay. Hi, my name is Rupesh. I am currently studying in VVIT College, third year, IT section. Now I am going to explain about TCP. TCP or Transmission Control Protocol is a backbone of reliable communication in networks. When you load a website, stream a video, or send an email, TCP ensures your message gets delivered safely and in the right order. Before protocols like TCP were invented, data could get lost or arrive out of sequence, just like letters delivered randomly. TCP fixed this problem by creating connections and checking every packet sent over the network. It's like having a strict courier that not only delivers every letter but also confirm that each letter arrives correctly and on time. That's why whether we are chatting, emailing or gaming, TCP is always working quietly in the background, making the internet stable and trustworthy. TCP services, features and controls. TCP provides several essential services to networks. Its most important job is reliability. It makes sure data isn't lost and everything arrives exactly how it should. TCP achieves this by using a techniques like error checking and recovery, which automatically resends any lost data. Another key feature is the three-way handshake used to start every TCP connection, making sure both computers are ready to talk. TCP controls how much data is sent with flow and cognition control, adjusting traffic based on current network conditions. Think of it like courier control for your car, smoothing speed up or slowing down and necessary to keep the ride safe. These services enable SL-free browsing, streaming and communication for users around the world. Key features of TCP. Some key features set TCP apart from other protocols. First, it's connection oriented, using a handshake process for a secure start. It divides data into segments and numbers. Should each one so packets don't get mixed up. TCP's error control means lost or damaged data is always retransmitted, guaranteeing delivery. Flow control makes sure the sender doesn't overload the receiver, kind of like pouring water slowly into a glass instead of all at once. Full duplex allows two devices to send data at the same time, similar to talking and listening on a phone call. And in times of heavy traffic, TCP cognition controls keep the network from getting clogged, which is vital for smooth, uninterrupted and communication. Anatomy of a TCP segment. Every piece of data sent over TCP travels as a segment. Each segment comes with a header that tracks important details like source and destination ports that steer the data to specific applications. Just as a street address guides a letter, the sequence and acknowledgement numbers are used like page numbers, keep, keeping everything in order and confirmation recipient. Control flags like SYN and ACK help manage connection states, while buffer size advertisements keep transmissions efficient. Finally, checksums help detect any errors in the data. With all these elements working together, TCP guarantees data is delivered properly and safely, even in complex network environments. Establishing a TCP connection, three-way handshake. Before two computers can exchange data over TCP, they go through a three-way handshake, a process where the sender and receiver synchronize their settings. The client starts by sending a SYN packet to the server, saying, let's start talking. The server replies with a SYN ACK packet, agreeing and also sharing its own sequence number. The client responds with an ACK packet, confirming both sides are ready. Once the handshake completes, both data transfer can begin. This process prevents miscommunication and makes sure both sides understand each other, leading to a smooth connection every time. TCP windows, sliding windows mechanism. TCP manages how much data is sent and received using windows. The sliding window mechanisms lets the sender transmit multiple packets before waiting for an acknowledgement. The size of the window depends on two things: how much free space the receiver has and current network cognition. For example, if the network is busy, the window size shrinks to avoid overwhelming the system. If things are smooth, it grows, speeding up transmission. Imagine a conveyor belt moving boxes. If there are plenty of space, it moves faster. But if it's crowded, it slows down. This smart balancing act allows TCP to maximize efficiency and minimize errors or data loss. Flow control in TCP. Flow control in TCP is all about balance. When a sender transmits data, the receiver tells it how much space is available in its buffer. Using the window size, if the sender pushes data too quickly, the receiver cannot keep up, resulting in lost packets. TCP solves this by letting the receiver communicate its capacity and the sender adjusts its rate accordingly. For example, downloading a giant file on a slow computer means TCP will slow things down for a smooth experience. This system keeps both ends working efficiently, preventing bottlenecks and dropped connections, regardless of hardware or network speed. Error control, ensuring data integrity. TCP is highly reliable because of its error control methods. Each segment includes a checksum which helps in detecting error during transmission. If the receiver spots missing or damaged packets, TCP automatically retransmits them. A unique feature is fast retransmit. When three duplicate acknowledgements arrives, TCP sends the missing packet right away instead of waiting longer. Imagine making sure every page of a book arrives in perfect condition and immediately correcting mistakes if a page goes wrong, wrong or missing. This robust process makes TCP ideal for transferring critical data, whether it's downloading software or sending sensitive information. Cognition control, avoiding network overload. Cognition control keeps network running smoothly even when many users are online. TCP uses several algorithms to detect the packet loss, often a sign that the network is overloaded. When cognition is found, TCP halves the sending rate, then slowly increases again as conditions allow. Think of rush hour traffic. If the roads get jammed, fewer cars are allowed through until things clear up. TCP learns from network feedback and adapts, preventing overload and making sure everyone gets a fair share of bandwidth. This ensures quality connections for all users, whether you are gaming, streaming, or working remotely. TCP, the backbone of reliable internet communications. In summary, TCP's advanced mechanisms, connection management, sliding windows, slow on cognition control, and error connection make it an irreplaceable protocol for modern networking. Reliability means data arrives correctly no matter the conditions. Understanding TCP not only helps us appreciate how the internet works, but also guides us in solving network issues and designing their better applications. Whether you are a developer, student, or IT professional, knowing TCP is essential for building robust and reliable solutions that power our daily digital lives.